Have you ever looked closely at a seedling? When seeds germinate, the first pair of leaves that you can see are called cotyledons. These are embryonic leaves that keep the plant alive before the true leaves appear. They're actually present in the seed before it germinates, and they take on the role of photosynthesis before the plant grows true leaves. They're usually shaped quite differently from the true leaves, as you can see in this coffee plant or in these little jacaranda seedlings. So if a seedling has only cotyledons and no true leaves yet, it might be tricky to almost impossible to be able to recognize what species of plant it is. But what you can tell is whether you're looking at a monocot or a dicot. Monocotyledons and dicotyledons, monocots and dicots for short, are two main groups into which flowering plants are divided. If you watch my videos, it won't surprise you when I tell you that the characters used for distinguishing these two groups are not completely reliable, and there are many exceptions. After all, these two groups do share the same ancestor, so there is overlap in certain characters. Even so, categorizing flowering plants in monocots and dicots is still a useful and helpful way to group plants. As you can already see from the names, the number of cotyledons serves as the basis for this division. If you think of a typical seedling, you probably imagine cotyledons coming out paired. Having two embryonic leaves is a characteristic of dicots. However, seedlings of many plants start their growth with only one leaf. These are the monocots. As opposed to dicots, where cotyledons are usually somewhat round, the first leaf in monocots is often linear or strap-like. Think of any grasses. Those are all monocots. But the number of cotyledons is not the only distinguishing characteristic between these two groups. That would be pretty impractical, as the plant doesn't spend much time in the seedling stage, and the cotyledons are not present for very long. When the plant is grown and it has true leaves, look at the venation in the leaves. While leaves of dicots have veins branching out from the midrib, creating a network, monocots have parallel veins. Look at a few of these examples. You might also notice that monocots generally have elongated to strappy leaves, while dicots' leaves are broader. Look at this trillium. What do you think? Is it a monocot or a dicot? Its leaves are broad with a network of veins, right? Well, it's a monocot. I'm showing you this example so you realize that there are exceptions and you should not rely only on one characteristic to determine whether the plant is a monocot or a dicot. Even though this trillium doesn't exhibit typical monocot leaves, it does have a typical monocot flower. Notice the number of its flower parts. If you're not sure how to recognize those, I recommend you watch my video on this topic, which I'll link down below. In monocots, sepals and petals, and generally the other plant parts, come in threes or multiple of three. Let's see. In this lily flower, which is a monocot, we see 3 petals, 3 sepals or 6 tepals, and a 3-lobed stigma that signals 3 carpels. So you can see that the flower parts come in threes. Same happens here with a yucca flower. 3 sepals, 3 petals, 6 stamens, and a 3-parted stigma. In dicots, the flower parts come in 4s or usually 5s. When we look underground at the roots, we notice that monocots have fibrous roots, all of them are usually the same size and there is no main root. Great examples are grasses, whose root system you can see nicely in these herbarium specimens. In dicots, there is a distinct taproot, which is the main root from which the smaller roots are branching. It's clearly visible in these seedlings of Bohemia. Vascular tissue, the system for nutrient and water transport, also differs between monocots and dicots. In monocots, vascular bundles are scattered through the pithy tissue of the stem, while in dicots, vascular bundles are organized into a single cylinder. But this is not really a characteristic you can readily see. However, what you can see is the lack of secondary growth in monocots. This means that monocots don't create cambium, so they don't truly become woody. The vast majority of monocots are herbaceous. Nearly all flowering trees are dicots, but not all of them. Think of the palm trees or yuccas. They definitely look woody, don't you think? They do have a cambium-like layer, whose cells expand to create more tissue, allowing the stem to expand, but this layer does not have the same structure as the cambium in woody dicots. And that's it. Those are the main differences between monocots and dicots. If you want to see more educational content, please subscribe to my channel. Thank you so much for watching, and I'll see you next week.